In our last lesson, we were working on graphing with intercepts. If you recall, we were starting off with a point on the x-axis, -3, and we'd graph that first. And we'll have -1, -2, -3. Our y-intercept point on the y-axis, counting up 1, 2, 3, 4, 5. 2 points are all you need, and there's your graph. Remember, the easiest ones come first when you're given the information. X-intercept, point on the x-axis, y-intercept, a point on the y-axis, 2 points, 1 line. Arrows at both ends, a line goes into infinity. The easiest ones where they're already giving you the information. X-intercept 1, 2, 3, 4, 5, 6. Y-intercept 3, 1, 2, 3. 2 points are all you need to graph the intercept. The x-intercept, the y-intercept, and there's your line. We then found out that we will sometimes have to find our intercepts. What does that mean? We're going to set one of our variables equal to 0 to solve for the other. In the first case, remember, if I set y to 0, that cancels out this term, leaving me with 2x is equal to 6. I'll divide by 2, and x is equal to 3. So that when x is 3, remember we're getting an ordered pair here, think about that. When x is 3, y was 0. We then have to find the y-intercept, which means x is equal to 0, using your same equation. And if your x is equal to 0, I'm left with -3y is equal to 6. Divide both sides by -3, and we'll find that we have y is equal to -2. X-intercept, y-intercept, you have a line. Let's just do one more. Let's set y to 0, and that's going to leave me with -2x is equal to 6. Dividing by -2, my x is -3. When it comes to solving for my y-intercept, x is equal to 0, which cancels out that term. Be careful, that leaves me with a -y is equal to 6. I now have to divide both sides by -1, and there's my y-intercept. So I start off with my x-intercept, and I'll see that that falls on my x-axis, 1, 2, and 3. And then when I go to my, I'm sorry, that's my negative. Let's switch it over here. 1, 2, 3. There's my -3. My -6. 1, 2, 3, 4, 5, 6. 2 points and a line. Okay, so now we've graphed with our x and y intercepts as well as a table of values. I'll save a few others for us to practice in class. Today I also want to talk a little bit about rate of change or slope. Rate of change is this ratio that tells me quantity changes in respect to another in a ratio form. If I look at this, slope is the slant of a line, and the variable m represents slope. We're going to use the slope formula and 2 points on the line to calculate slope. We're also going to find out that there are 4 basic types of slope. We're going to read a slope from left to right. It can have a positive uphill slope, a negative downhill slope. If it's a horizontal line, it'll be a 0 slope. And notice that I'm underlining the z's here to remind us that horizontal is z and a vertical line is undefined. Let's just try a problem or two. Well, actually, the first way, before we calculate with the formula, we can actually calculate slope by counting rise over run. What do I mean by that? We're going to count the boxes. If I'm giving a graph and it's a linear equation, it's a line on a coordinate plane, I'm going to count the number of boxes that rises or falls over the run. So I'm going to go from 1 point and count up 1, 2, 3. So m is equal to a ratio of 3 over 1. That means my slope is a positive 3 going uphill. My second one, I can take any 2 points that fit in the corners. I'm going to count down 1, 2, 3, and over 1, 2, 3, 4. The ratio here going downhill is a negative 3 over 4. I could do that again if you watch. Down 1, 2, 3, and over 1, 2, 3, 4. Again, it's going from the corner point of one to the other. So that's how I can read it from a graph. But more importantly, we need to be able to use this slope formula. We're going to be given 2 points on the line, and we're going to set this up. This first point is my x1, y1. The second one is my x2, y2. It just represents the 2 points, the first point and the second point. Substitute in what we know using the formula right here. Y2 is 14, y1 is 8. Find the difference, 6. 5 is my x2, 2 is my x1. 5 minus 2 is 3. Simplify, it's a 3 to 1 ratio, so my slope here is a positive 3. Let's take a second example. Once again, we see that we have my formula, and I'm going to calculate my rise over run, and I have it set up here. Let me just move it so it's easier to see. I'm going to start with my change in y, which is 8 minus 6. And 8 minus 6 will give me 2. On the x's, change in x is going to be 2 minus a negative 4. Putting that in parentheses and then adding the opposite, I'll get 6. That can be simplified to 1/3. There's my slope. We're going to do many more examples in class, but these are a couple in case you are watching the video and like to go over the lesson. So we'll do more today during our session.